All right. I want to start off by saying again, for those of you who maybe weren't in the room before I said this earlier, I think taking a note for this lecture would probably help. There's going to be a lot of information. This one's going to be a doozy. So prepare yourselves. And I want to reiterate again that this one's going to be a lot of information. If you don't get it all, don't worry. All right. Like, please. Okay. So, this next sprint is on HTTP and basically making requests to an external server from inside of a React or a React Redux application and fetching external data from a server and then doing something with that within our React Redux project. So we'll be covering a couple of different topics that you'll need to know about in order to perform this kind of task. So first off will be a JavaScript language construct called promises. After that, we'll be talking a little bit about HTTP requests within the context of a React Redux application. And then we'll need to go a bit into an API that allows us to actually perform those requests. And then lastly, there's going to be a helper library, middleware that will be tying into our React Redux application in order to help us make the HTTP requests. So there's a lot of distinctive parts that will all kind of come together within this sprint. First one we're going to talk about are promises. So if y'all see my screen, right? I have this Replit up. So we're going to walk through some promise examples. Let's see. Okay, so what is a promise? You can think of a promise as the example I'm going to give is, for example, if you have a friend who has promised to pay you $100, that he says he'll do it by next Monday, for an example, right? So that's like a normal promise, right, in like the real world, right? Someone like an IOU, they're promising that they're going to give you money by this certain time period. So this is a promise. And if you think about that, there are a couple of different states that this promise, that your friend promising to pay you $100, there are at any point in time, there's a different state that this promise could be in, right? It could be either pending, meaning that next Monday hasn't arrived yet, and so he still has time to make good on his promise, and nothing has happened yet, and you're still just waiting on that date. And then next Monday arrives, and then he can either, he can stiff you or he can give you the money. And so the three states I'm talking about are pending, where next Monday hasn't arrived yet; rejected, meaning that he didn't fulfill the promise. The date arrived that he said he would pay you and he didn't pay you. And then resolved, meaning that the date arrived and then he did what he said he would do. He paid you, right? So this is what a promise is kind of in real life, or an example of a promise that, kind of a simple one you can wrap your head around. And actually promise objects in JavaScript, they mirror these exact same states. And they kind of represent this same idea. So first off, creating a new promise, you just use the new keyword and then with the promise constructor. And the promise constructor takes something that's called the executor function. So you pass it this callback, and you always give the callback this thing called resolve and reject. We'll get into these a bit. So just know that this line right here, this is how you would instigate a new promise, okay? And we're storing it in a my promise reference, right? So we're going to go into a bit of an example. So this is kind of the situation that we were talking about just now. Right, so if we're going into this situation, let's say we have a variable representing your balance. You have $10, let's say. And then we have a variable representing our friend's balance. Let's say he has $200. And so here we have a function called will get paid back. And this is the promise object that I was just talking about earlier. So new promise takes in resolve and reject. Let's see what this looks like. So basically inside the body of the resolve reject function, this is where you kind of lay out the logic of the promise, right? So in here, when it comes time, let's say next Monday has arrived, and this is the logic where the check is performed to basically see if the promise is going to be fulfilled or it's going to be rejected, resolved or rejected, I should say. So first in this if here, this is basically the case where your friend actually pays you back, right? So let's say he'll pay us back if he has the money. So first we do a check friend's balance. Let's see if it's greater than or equal to the amount that he owes us, $100. So we do this check, and if it passes, then we take $100 out of his account or his balance and then add that to our balance. And then at the very end, now that this transaction has happened and he successfully paid you, you call resolve with whatever you think of resolve here in this case as being like a special kind of return statement that you use within promises. So because we are in the case where he successfully paid us back, or the promise is going down the path that it was supposed to go down and he didn't stiff us, then we call the resolve function and then pass in your balance in this case, because now this is our increased balance. Otherwise, we go into an error handling mode basically. So else he didn't have the money and he stiffed us. And so here what we're doing is we're casting a new error and saying your friend only has a balance of, so for example here, let's say instead of 200, he had $90. Actually, sorry, I should show you guys what happens here. Okay, I'll show you guys that use case in a bit where if he only has $90, but I want to continue on for a little bit. So inside of the case where he decides to stiff us, what we do is create a new error, and this tells us that, oh, he didn't have enough money. And then we create this error, store in a variable, and then we call reject with the reasoning, okay? And then to actually run this, we'll have another function and we'll do something. So this is the function that we would actually call to run this promise, okay? So what's going on in here, awesome. What's going on in here is this function called confront friend. This is representing us, like next Monday has arrived and we meet up, and this is now the kind of the situation that's going down. So confront friend, inside of this, we call this promise, okay? We'll get paid back is this function, is this promise right here. So we're saying we'll get paid back, run this, and then once it's run, we do this thing. Promises have these methods called then and then catch. So basically what this means is we ran the promise, whatever happened inside of it, okay? We either got paid back or we didn't, and then go and do something else with whatever the promise resolved to, okay? So this then is assuming that the promise was successfully resolved, then go do something else. And in this case, we're just console logging the resolved value, whatever was called inside of the resolve function, which was your balance, okay? Otherwise, this catch statement handles the error case. So if we'll get paid back got rejected, if this promise went into the reject state, then this method, this dot catch method, catches it. And then here we'll just console log the reason here, which is saying your friend didn't have a large enough balance to pay you off. Okay, so and then we call confront friend down here and actually execute this. So what happens when we actually run this? Okay, so this is the case where, because friend's balance was 200, the promise successfully resolved. So what happened is we called confront friend. So confront friend goes in here, and then it runs will get paid back. And then inside will get paid back, it goes through the logic of checking the balances and making sure that your friend had enough money. And then because he had 200, which is less than or equal to 100, then it goes into the then branch. And then it got this call resolve your balance, then received that. And now we're console logging this, right? Because we got promise resolved with value. And then this resolved variable here is what this resolve function returns. Okay. Otherwise, now let's go see what happens when instead of if he didn't have 200, if he instead had $90, and now this is going to go into the case where he didn't have enough money. We run this, we see that it returns promise was rejected with this error, and this is the error that we gave it, this reason, right? So it went into this .catch branch, and it received an error, which was the error is this reason that reject got called with. This gets cast as our error, and then catch gets this, and now we console log it. This is exactly what's happening here, right? And your friend only has $90, so he didn't have $100 to pay you back. This is a kind of an example of kind of the flow of promises. Okay, so and you might be wondering, you know, kind of what's the point of this? Why is this important? The important thing is that is happening inside of the confront friend function, right? Because you can execute this promise, and then when it finishes, either it was resolved or it was rejected, either way, you can then specify it to continue going to do other things in a single flow, right? And this all happens asynchronously, right? Like, so you can have this function, and then you specify the promise, and then only when the promise finishes will that dot then or dot catch occur. So it'll wait on the result of the promise. And so promises are really good for handling asynchronous executions for cases when you don't know when something is going to finish. So in this case, let's say, you know, it's like a Thursday before next Monday, and next Monday is when your friend is supposed to pay you back. And so if it's just Thursday, and you know we still need to wait a few days, you can lay out what exactly the flow of the promise is going to happen in the confront friend function, and you have all the logic of what the promise is going to do inside of will get paid back. And then you just specify, even though it's only Thursday and it's not Monday yet, you just say once Monday arrives and the logic occurs and we figure out whether the promise was resolved or rejected, now go do this afterwards, or catch, or how you handle the error. And this would all happen prior to Monday. Okay, so now let's see. Basically, my point now is that you can we can do more with this then and catch than just have a single then and a single catch. You can chain these into really long promise chains. So you can execute really complex like flows upon the completion of a promise. All right. So now in our fictional scenario, let's go on and say, okay, you know, we've gotten the money. Let's change this back to 200 first. And then you see we've gotten the money. Now what are we going to do with it? Obviously we're going to spend it, right? That's the thing that would happen next. And so we have this function here called spend money that basically represents this case. Okay. So the spend money function just takes in a balance, in this case, our balance, and then sets it to 0 and then just console logs out or gives us a message saying what our new balance is basically zero because we spent our money now. And then because this function is used inside of a promise chain, you would need to call resolve with this new message, because now this is the next stage of our of the state of our promise or of our balance, right? So you need to then call this resolve with saying, this is the new message. This is now the thing that gets returned from the promise. And so the way we'd use this is like so.
Sean, can I ask a quick question?
Yeah, go for it.
Where are the resolve and reject functions actually being defined? Like what they do? Is that somewhere in our
Those
code?
are methods that are actually on the promise object. So you don't actually need to define those. What you should know is that you call resolve in the case where the promise was successful. So you resolve with whatever was the result of the promise, or you reject with an error in the case that the promise did not fulfill correctly.
Gotcha. You can pass in whatever. Can you pass?
Yeah, you can pass in whatever pieces of data. Just think about, the thing you pass into resolve is like whatever you would actually call inside like a normal return. So just think of resolve as a special return statement for promises. So basically what resolve is doing is it returns the piece of data that you pass it, and then it puts the promise inside of the successfully finished phase, right? Because I was talking about that there are three different states that promises can be in: pending, resolved, or rejected. And so think of all that resolve is doing is returning the piece of data you pass it, and then putting the promise inside of the resolved state. And reject is doing something very similar. It's just that instead you pass it an error message, and then it puts the promise inside of the rejected state. Okay, so inside the confront friend function, now we can call an additional .then method, and then with passing it the spend money function. So now this flow basically represents execute the promise. We see if the promise transaction occurred successfully, and then if it did, we say then go and spend the money, right? And then what's nice is with .catch, if an error of any sort occurs anywhere along the promise chain, the entire promise chain, that will get caught by the .catch method. So you only ever actually have to define one catch method inside of a promise chain, and it will handle all of your error handling within the entire flow of it. Right, so we're back in the case where our friend had 200 and he had enough money to pay us back, and now we run this new chain of ours. Let's see. Okay, perfect. So promise resolve. So now this entire chain here inside of confront friend, we get to the second then, it resolves successfully, and now it prints out what our new balance is at the end of the promise chain after we added in the spend money function. So now it's saying our balance is now $0. So we successfully got the money from our friend, and then we spent it all, and now our balance is 0. And then we go back again to the case where he didn't have the money to pay us. The exact same thing still happens because he didn't have money to pay us. And so the failure occurred back inside of the we'll get paid back function because it fell into this else clause, and then catch caught that error. So we can have a whole bunch of these then statements before the catch function, but because the promise failed at the initial stage, it doesn't actually matter, and it'll get caught right then and there from the beginning, and then none of the extra then met calls will execute. Okay.
Hey, Sean, I have a question.
Yeah.
So the balance in the spend money method.
Yeah.
I mean function. Does that have any relation to the your balance all the way at the top, or is it just like are they just separate?
That's a very good catch. These are actually separate. So
okay.
Well, it's separate in the sense that I'm passing in a reference to the your balance. So what will actually happen here is we're not, like, for example, if we console logged your balance here, I believe this should still be 10. No, this should still be 100, assuming that the promise executed correctly. And then inside the spend money, I'm not actually changing the value of your balance.
Okay, all right.
Yeah. One sec. Message in chat. Okay. There's a question asking, what does dot then spend money pass to spend money? Right. Okay. So to answer that question, inside will get paid back. And so I want to reiterate again with the dot thens, these only occur in the case that the promise resolved correctly, right? Otherwise it goes to catch. So thens only occur when the previous stage also occurred successfully. So it only happens inside of the case when our friend pays us back. And then gets called the dot then method. You pass it a function, and then it passes the whatever data you passed to the resolve function in the promise into the function that you specify inside dot then. So spend money is receiving this your balance argument, right? Because it takes in a balance, and we're passing in this balance into the resolve function. So when this promise finishes resolving, resolve then takes this piece of data that it gets passed and passes it further down into the promise chain, into the next dot then method, right? So your balance is getting passed into this balance argument inside of spend money.
So it is changing to 0 then. Or
you're getting into issues then with passing a reference versus passing a value. That's altogether kind of like a different issue.
Sure.
Yeah.
But my question is, what you are passing to the property of spend money, like nothing, or the balance, or nothing?
Balance. We're passing in your balance. But it's a reference to your balance.
Passing what we resolved, we are passing to spend money function.
Sorry, say it again.
What we resolved, like what we resolve something. So we resolve, and then the conference friend gets this result, and the dot then from will get paid back, send the resolved to the function I'm calling.
Just whatever you passed into resolve. We're not passing the entire resolve function into spend money. Just whatever resolve got called with.
It.
Yeah. Exactly.
Yeah. Can you just console.log what is coming?
You want to console log here.
Inside of the spend money function, like the balance.
Sure.
Before it's attributed to 0.
Sure.
Yeah. So let's see what we get. We get nothing, or it's just don't console it.
Let's see. Interesting. 1 second.
Basically, if I set my your balance before we came back to this, just if I set directly the your balance that is locally global, we will iterate over, right?
Yeah.
Oh, yeah.
So see, the reason we didn't get anything is because we never got to the spend money function because it didn't. Yeah.
Absolutely.
Okay.
Oh,
we
yeah.
got 110.
So now we got a 110.
Yeah.
So
exactly.
what if we now console.log outside of spend money?
So
it's supposed to be 0.
So you want to console log your balance?
Yeah. Or it will be 10. Or 110. 110.
Okay. Yeah.
2.
That makes sense because we're actually mutating it here.
Yeah.
So this variable here actually gets changed. But then since we're passing a reference into balance, that doesn't actually update the your balance variable. Again, it doesn't set it to 0. It's only setting it's only setting the balance variable inside of this instance. But this is,
your balance will be 0 if we directly relate it to spend money or not, because looks like it will be not 0 even if we make it, because console.log will run right after the promise and not exactly like right after they spend money, right?
I'm not sure I understand.
Can you just change balance to your balance?
I suppose you could, yeah. You could do,
no,
you mean here?
Just for getting in touch, like, yeah.
So yeah, you could do this as well, and then there'd be no reason to have spend money taken a balance. And so then you could just do it. Yeah, sure, one sec. Let's do this real quick. And then we'd have to change these here. Yeah, okay. Right, and then if you console log, did not get here. Oh, there's still 110.
I think it's got in there. Yeah, absolutely got it. And it happened what I think it will happen. Because you are calling an external function.
Yeah.
It's not updating the variable, right? So, okay, I'm done with my question.
Yeah, okay, sorry. This is all kind of besides the point. Initially, I had it so that, so you guys could see the flow of what is happening inside of the dot then calls, so I could tell you guys that what gets passed into the functions that you hand into dot then, which is whatever value you pass into the resolve inside the promise previously. Okay. Blah. Okay. Right. So this is a quick kind of overview of promises and how the flow of them works. So like I said earlier, they allow you to wait for something to happen that hasn't happened yet. So they're really handy for asynchronous control flow. So when it does finally happen, when we'll get paid back gets called and next Monday has arrived, now you can kick off all these events in response to whether the promise resolved or rejected. Okay, so from here, this leads us pretty naturally into making HTTP requests. What would it affect if you did then spend money your balance? Good question, Jake, but let's figure that out afterwards, because this is all kind of tangential to what we're actually trying to get to in the sprint, and the sprint this lecture is going to be pretty long already as is. So yeah, let's talk about that afterwards. So yeah, here we'll go on to talking about HTTP requests. So quick overview of what HTTP requests are basically the thing you should know about HTTP requests. There are four kind of main types. There's the GET request, which is for just for fetching data off of a server, just for reading it. And then you can make a POST, which is where you actually add a new piece of data to the server. And then putting is updating a piece of data that already exists on the server, and then deleting, which deletes a piece of data off of the server. This is like remote access to some data that lives on a server that is somewhere out on the internet, okay? So these are the kind of the four main types of HTTP requests. And in the case of this sprint, we'll be making requests to an external resource that lives somewhere on the internet. So, and you do that with HTTP requests. And so promises lend themselves really well to making HTTP requests, because when you actually make a request, let's say we make a GET request. Let's say we just make a GET request. That GET request will not immediately return, right? You won't immediately get the result back. And so what you would want to happen in that case is you would make the request, and then you would have to wait some amount of time for the server to respond with either an error or the result of what you asked for, right? So either the server successfully responds with what you wanted or it didn't. And then since there's a period of time where you need to wait for the server to respond, that's valuable processing time, basically, where your processor could be executing on something else, or your node code could go on to wait on another thread, basically, and go do something else, per se, because you don't want to just wait there and have your processor idling, just sitting there waiting for an update and not doing anything else, right? That's valuable time that you could be utilizing. And so promises lend themselves very well to this kind of asynchronous flow that we want to achieve. So let's say we kick off a GET request to some external web server that the promise waits, right? It'll basically, inside of the promise body, it will check to see if the response was successful. And then if it was, then inside of our promise chain, we would have a whole bunch of other, then calls to specify exactly what we want to do with the data that we got back from the server. Otherwise, if it gets an error message from the server, like it got a 500 or 404 not found or whatever, then we can handle it inside of the .catch method. Okay, so we'll go into a more concrete example. So that was just kind of talking about HTTP requests in an abstract fashion. And what we'll actually need to do is, we'll need to make HTTP requests through some kind of client. And so we'll be using this client called Axios, which is a promise-based HTTP client. So it's called something like this. And so if I want to kind of go into the example that I was just talking about in the abstract, let's say we wanted to query let's say we want to query Google, and we wanted to get the results of making a search on Google, let's say capybaras. So we would do something like this. We would call axios.get because we want to make a GET request, and then you would specify the URL that we want to query on. And so in this case, it would be, because we want to do a search on capybaras, let's say. And this is basically equivalent to you actually just going to google.com and then inside the little text box asking what you want to search for, typing in capybaras. This is the URL you would get as a result of that. And so we can make this GET request instead just from within our code to do exactly the same thing. And so axios.get, or any of the Axios methods, so you can do axios.get, axios.post.put.delete, all the different HTTP request methods, all of these return a promise. Okay, so the way that this would then, the flow that this would look like in your code is you would then do whatever, right? So in this case, let's just console log the response. Right. So this would just, we're just printing out whatever the external web server gave back to us in the case that it was successful. Otherwise, then we'll get back to this error. And then we can just console log that instead as well. It's kind of how the flow of this would look like inside of an Axios call. Unfortunately, inside of my REPL, I cannot show those because I don't think I'm able to. Is there another? Actually, I'm not. Yeah, does JSBin let you import like libraries and stuff via npm. Could I do this here? I'm actually not sure. Add library. Okay. Let's see. One sec. Let's see if they have Axios. Can't search on this. That's really dumb. I don't see it. Yeah, sorry, I don't see it in the list of libraries they have here. JS Fiddle. Yeah, let's try that. Collaborate, external resources. Yeah, could do that as well. Let's see. Ajax calls. Okay, let's do, let me try to think. Let's do this. So let's make a new, no, what I want to do is, one second. Yeah, you'll be using Axios in the sprint. Or I'm just trying to show you guys the result of that actual query that I had, that Axios get call I had to google.com for capybaras. Sorry, it's a little spur of the moment. So we can do, let's see. Okay, and then we can do side here. Do that import and then type in the search term or the URL that I had earlier. Okay, now let's try running this. Expected that. Oh, it didn't take it. Darn it. Does it require? Oh, yeah, good catch. That's not. Okay, but I'm still not sure if the import will take. Ugh. If we did require, is that what it needs to do? I already did that though. It's inside the node modules. Oh, let's try this real quick. Let's see. Ugh. Right. Yeah, choose const. Okay. Come on. Does it need to be in a string? Yeah, okay. Yeah, okay. Awesome. So literally what we got back was all of the HTML for for the web page that pops up when we say google.com, type in capybaras. So we're getting back all of this HTML basically. So that's what gets returned inside of this get. So we see status 200 and then a bunch of headers and stuff. Yeah, and then this is the actual data. So you can see it's all HTML, it's doc type HTML, blah, blah, blah. No, browser too. Here when I just, but this is when I actually like typed it in. I think you wanted the network tab of when I actually made the GET request in Axios. Well, anyway, yeah, so we see it work there. So again, this is kind of the flow that I was talking about. We called Axios GET for this URL. The console logged out the response. Okay, so this is kind of the flow that you guys will be using for the sprint. You'll be using Axios in this way. Cool.
Sean, do you mind posting your code block that you have thus far in Slack?
Just this one here in the demo.js?
No, from your REPL.
Oh, in the REPL. Yeah. I'll do that at the end, don't worry.
All right.
I'm gonna move on for now. Okay. So back here. Let's see. Right, so okay, okay, so Axios GET, what this line does, it returns a new promise, and then what actually happened was because google.com successfully returned the response, then we hit the .then call. But so there's this point between this Axios.get line and then this then line. Between lines 3 and 4, there's like this period of time where it was waiting, where the promise was in the pending state, right? Because Google hadn't returned yet, because we're making a remote call, and that takes a lot more time than if you did something just locally on your machine, because it needs to, go out and travel over the internet and everything and out to the network. And so this is why promises are great for handling this kind of thing, because so we can wait for a response from our remote server, asynchronously. So like this time in between this get call and this .then call, our processor can go and do other stuff. It's exactly kind of the flow that we want to achieve when making HTTP requests. And so this pattern is going to be really important in this sprint, and going into the future when you guys are making HTTP requests, which you'll be doing a lot, because if you're working on web applications, the application can't do much if it just lives on your machine and doesn't talk to anything over the network, right? Okay.
What error?
Mm-hmm.
What error will be logged, and where does it come from?
So the error, okay, for example, let's just do, I don't know, let's do something like that. Okay, so let's say we misspelled Google. Actually, I'm not sure. Hopefully this will just return an error, and hopefully this isn't like some real site. that with like a bunch of malware on it or something. Yeah, so am I comfortable doing this on my computer? Okay, let's do it. Okay. Unhandled promise rejection. Oh, what? Oh, okay. Okay, so yeah, we see that it did get into the catch clause. Otherwise, that error wouldn't even have popped up. Let's see. Yeah, so like 503s, 404s, like let's say we queried Google with a search term and it just didn't have anything on that page, right? Then it would return, like I was showing you earlier here, inside of the successful response, we got a status of 200, meaning that the request was successful. But yeah, otherwise, if we made this Axios.get call to something that Google had no page for, or returned to 404, then accordingly we would get 404 in the status, and then you would then handle that accordingly inside of your .catch call. Yeah, so that would be like an example. Actually, let's try running this one more time now that I fixed that typo. Okay, yeah, okay, perfect. So here, status 404 not found. So we hit tried to go to a URL that doesn't exist apparently. And then, this is what the data in this error looks like. This is another piece of HTML that I'm guessing, just returns. Yeah, this is that little Google page that says 404, we don't have what you're looking for. And I know that because it always says that's all we know. They always say that. Okay. So it's an example of an error. Okay, so you'll be using this Axios utility inside of our sprint. And now I'm going to get into talk a little bit about middleware. So basically, in order for you to use Axios, I mean, you don't necessarily need the way you would use Axios inside of a React application. And it's not really that there's a problem with you using Axios inside a React Redux context, but it's that React Redux initially doesn't know how to handle kind of asynchronous control flow. So let me talk a little bit about that. So there's actually this helper library called Redux Promise that we'll be using, and this basically teaches your Redux application how to handle asynchronous control flow. Okay, so here we'll be doing a really quick kind of like mini sprint that goes through some of these topics that I've touched on. And so this is just the code base for the mini sprint. And so we're inside the index.js file of this code base. And so this is where you're setting up, your store and wrapping your app inside provider, right? Like all that good stuff from the Redux sprint. But the way you actually add in middleware, and so, sorry, I forgot to say, Redux Promise is a piece of middleware. And you can think of middleware as, they're pretty much just like utility libraries as well. But they're really easy to kind of just plug in to your Redux applications, right? So I mean Redux makes it that way. They wanted to make the library, the Redux framework, like really extensible with middleware, and so they made it really easy by saying if you want to add in Redux Promise, what we want to add in, then all you do is call this apply middleware function. Right, so this one line is all you really need to add if you want to apply a piece of middleware to your Redux application. And so we call apply middleware, and then we would store whatever gets returned inside this create store with middleware variable, and then inside of provider, we pass it into the store. And so the middleware has already been applied in this case, and then we just pass that into the store inside provider. And now our store knows how to handle promises, basically. Or I would say it knows how to handle promise behavior. Okay, so what I want to get to now, okay, so I want to talk a little bit about what I mean by, now that we've added in this middleware, how does your Redux code change as a result? Okay, so inside of Replit, basically what will happen is you'll be writing your actions slightly differently. So the new flow of it is now, inside of your components, you'll be, when you kick off an action, within that action is where you'll start making an HTTP request, okay? So the point of this mini sprint is simply, all you need to do is fill in this one function here. But what happens is this is a get friends like action. So let me just show real quick. Okay, so we're going here. So let me just show you real quick how to run this. Run this project after you guys pull it down. So first off, inside the root, you're going to want to do node server.js. This is running a little local server, and this is the server is basically mocking like a real remote web server in this particular case. You need to do that inside of a terminal, and then in a separate terminal, you go into the same directory, and then cd into this HTTP directory. And this was just made with create React app. So inside HTTP is just another React app hooked up with Redux. And then here we can just, after you npm install, which I've already done, then you just do npm start. And I'm just gonna show you guys the initial state of this application, of the mini sprint. Time to give you guys an idea of what you'll need to do when you actually get into it. Right, okay, so we get into npm start, and you'll see that there's a bunch of errors because this isn't working yet. And so you'll need to, the only thing it's missing right now, so we have this friends list component, and basically what you want to do is, what you're going to be wanting to do for this mini sprint is you're going to be fetching an array of friend objects off of the server using a GET request. And then once you populate it, then this component will then get that array of friends as props and then render them all. And so what you need to fill in is this one action here, this get friends action, which you'll see that the friends list component is trying to call inside this component mount. So inside this component, once it mounts, it tries to call this. But right now it's not implemented, and so it's trying to do all this rendering, and there's nothing for it to render. So your task for the mini sprint is to fill this out, and I'm gonna give you guys kind of a little hint on how to do that. Right, so kind of the pattern, the more generic pattern that you'll want to use for Axios with Redux Promise is your actions will look slightly different from how they did inside of the Redux application. And so the general pattern will look like, you know, let's say this is a generic action. And what it's going to look like is typically with one of these, you would, sorry, actually action creator functions, right? So this is like a typical action creator pattern. And typically this would return, you know, your action type and then a payload of some sort, right? With whatever data you want the action to dispatch. Whatever, like your user did something on the UI, and then inside the payload, the data relating to that change in the UI gets passed in the payload. And so instead, in this case, what you'll be doing is you'll be kicking off the GET request. And so it'll be, in this case, whatever your URL is. right? So this is how your actions will basically look like now. And then inside of payload, you'll just pass it this promise. And so basically what Redux promise teaches Redux to do is how to handle, this particular case. Inside of action creators now, inside of payload, we're just handing it the promise instead of, whatever data was updated as a result of the UI change. And that's all that really needs to change inside of your code. So your reducers will actually now just be able to handle this the same way that they did. And so you guys can see inside of reducers, like this is like a normal looking reducer, right? Inside the get friends case, it just returns action payload data. So this is exactly how you would do it normally inside of your Redux applications. All that really changed is here, we handed it the promise as the payload. Okay, so going through all that, I think you guys should be able to should have enough information now to complete through the mini sprint. And this should be relatively quick, but I think we'll still give you guys like, half an hour, maybe 40 minutes or so. So get this function to work such that, once you run npm start, your components will be rendering successfully, and then take some extra time to do things like look through this this code if you need some more of if you need to look at more Redux code, because I'm sure you guys probably need to do that. And then also inside of the mini sprint repository, I have some helpful links on promises, Ajax, stuff like that. I didn't actually talk about Ajax itself because I don't think it as a concept it's like a high level kind of concept that doesn't really affect what you guys are actually doing. So to do some reading on that, just so you're aware of what it is. But in terms of what you guys are actually doing for this sprint, you guys have all the pieces you already need from this lecture. So let me paste this into Slack, and this is the repository that you guys will be cloning down just for this mini sprint. So if you guys want to get going on that right now, just on your own, so it's only we'll give you guys half an hour or so, just kind of try that. And don't worry if you don't finish it. We'll go into it after half an hour or so. So just clone that down and try to look through it on your own and try to figure out how to get the application to render on your own without a pair. And then we'll reconvene at, let's say, 2:40. Okay? Yeah, so let's do that for now, and then we'll reconvene in about half an hour. All right? Talk to you guys then.